Okay, we're going to continue exploring the preamplifier power supply today, the Tektronix Type 127. So far we've verified that the power supplies are working okay and there's something coming out of the calibrator, but the whole thing was upside down back to front on the bench, so it was very hard to do anything with it. Now I'd like to see if we get actual outputs from its outputs. I've got a couple of plugins in here ready to test. And we'll have a closer look at the calibrator as well. I'm suspicious about one valve in here. There's an ECC81 which appears to have no getter left, so I think that might be cracked. But let's switch on and see what happens. I've never tried it with two plugins in before, so who knows, power supplies might be overloaded. Dunno. Let's switch on and find out. So first things first, the red light comes on, which is always a good sign, and we should have a click in a few seconds as the power supplies come up. I've got the scope ready over here to take a look at what's going on, and on the end of this cable is a plug I can plug in. There we go, power supplies are on. Nothing seems to have caught fire, which is always a good start. So let's simple things first. Calibrator, let's start it at 1 volt. And I've got the input on the scope set to 0.2 volts per centimetre, so we should have a 5-division trace. Oh, that doesn't look too good. What's going on there then? A lot of hum. I think we have serious unhappiness. Oh dear. Yeah, calibrator is not healthy. We've got massive hum on there. Maybe due to bad connection, or might be serious power supply problems. It's behaving like it's not earthed at all. What's going on? It's weird. Gosh, there's awful stuff coming out of the other outputs as well. Maybe that we've got power supply ripple issue. What about on there? Oh, that's got hum on it. Or has it? No. Or is this just a dodgy adapter? No. No, that's not good news, is it? I think we've got a serious power supply issue. Well, let's try taking out one or more plugins. If we unplug one, reduce the load, does it get better? I shouldn't do this with the power on, but I'm going to do it anyway. No, that's no better. And I'll go on. No, still something's not right there, is it? Maybe this cable's faulty. It's like we've got a whole earthing issue. Calibrator output is definitely visible on there, isn't it? But that's weird. Wasn't expecting that. Oh, I'll try another channel on the scope just for good measure, but it probably won't help. Oops. No, that's just as bad. No difference at all. There is an issue in this room that the scope doesn't have an earth connection of its own because of the way the wiring's done. Maybe what we're... That doesn't look like 100 Hz ripple though, does it? That looks like 50 Hz. So it's not power supply ripple, probably. It's very odd, we didn't have this problem before. Let's try it, instead of using that thing, we could try connecting another ground to a scope probe, since they've got crocodile clips on. See if there's actually a fault in this cable. If we connect ground there, oh, it does help. This is a faulty cable. Well, that was easy. Oh, there's an actual power supply fault. That looks better, doesn't it? Okay, well, we'll switch off and put these plugins back in, and then switch back on. So, lesson 1, check your cables before you start. been using that one for ages, but never from two pieces of equipment that don't share a ground otherwise. Okay, start again. So, ground is being provided by this scope probe for now. That'll do. I can't bother to go and find another cable. So let's try again with the calibrator. 1 volt output. It's on 0.2 volts per centimetre. Let's see whether we get the expected result. I think all bets are off until the relay's clicked in, sitting there at 0.4 volts. Oh, there we go, look. That's more like it. So we have an output. Is it at roughly 1 kilohertz? Near enough. Is that scope trace visible? Yeah, that's right, there we go. 1 kilohertz, and that's 5 divisions, close enough for me. We double it, halve it. It's pretty good. Yeah, 0.2 volts at 0.5 volts per division gives you 4 divisions. 10 volts at 5 volts per division gives you 2, 20, 50 volts, 100 volts. It's all pretty good. Yeah, calibrator's working fine. Edges of the waveform are not as nice as they could be because the grounding's not brilliant, but that's not the device's fault. Okay, now let's check the outputs from the preamps. So we'll start, let's just use this plug-in for one. I don't know what the gain is supposed to be on this, so let's start with a 1 volt signal. So we'll connect the scope to the positive output on the left channel. Oh, there's nothing there now, which is a good sign. That's channel 1, left channel output. Does the position control have effect? Oh, it does have a small effect. Not much. But we're probably on the wrong range. So if we set this to 0.2 volts per centimetre and connect the 1 volt calibrator, another adapter, because this thing has UHF connectors on, which is not helpful, into there. Right, that should give us, we should find some way of making that a 5 division signal. That definitely isn't 5 divisions, is it? But it is appearing in the output, which is a good sign, and the scope's triggering on it. All credit to the scope. So that's 0.2 volts per division, 1 volt output. Let's see what we have to set this to get a 5 division trace. Put the DC offset on there, disappointingly. Looks like, oh, there you go. 0.1 volts per centimetre does the trick. Hello. That looks alright, doesn't it? A bit of drift, but you expect that in valve gear. So 0.1 volts per centimetre is the right answer on the scope to make this scale here accurate. So we should now be able to reduce that to 0.5. 1 volt. Yeah, so if we put that on 0.1 volts per centimetre. Reduce that. Oh dear. It's not nice, is it? Something wrong with the input compensation. This plug-in hasn't been used for ages, so switch contacts are a bit messy. Okay, so let's try the centering. That in the middle when it's grounded. That one DC. We ground this one. Now that's a bit offset, but we can bring it to the middle quite happily. That's alright. There we go. And does the invert position work? That's 0.2 volts per centimetre with a half volt signal, 2.5 divisions, invert it. These switches were always awful. Yeah, it does work. That's the plug-in that's not great. Okay, so that's A output of channel 1. This left channel is working. Does the B output work? Let's make this out of here. Should be the inverse of the A output, I think, because it's a differential output. That's, where's that gone? Way off the top of the screen. It's not what I expected. Maybe there's offset. No, that's disappeared altogether. That's no good at all. It's not coming back. Turn everything down. No, all bets are off there. Can we see anything at all if we reduce the scale? No, there is a signal there, but it's, goodness me. So that works, but there's a big offset on channel B. How big is the offset? Measure it. So we've put that's at 20 volts per centimetre, and we switch that on. Oh, not too bad. So 2 volts per centimetre, it's 5 divisions, so it's sitting 10 volts above ground. Shouldn't be really, and there's an adjustment for that. I wonder if we should tweak it. Is the scale looking otherwise correct? That's the question. 2 volts. Yeah, we've got an output. Ooh, right, step is clipping up against the positive rail. Well, we could try adjusting the offset, couldn't we? I suspect there's something else wrong. DC level output B. Here it is in the top here. Oh, well, that makes a big difference. Just that. But it's still, no, it's still clipping in a strange way. I don't know if you can see that with my hand in the way. We can adjust the DC level, so if we put that back to ground, so if we can bring that back on the screen, we can. So that should be going negative. Right, we've got the scale right now, but no, it's clipping. So there's a big offset on the B output, which is, oh, wiggling the valve seems to help. Aha! What's going on there? That's not a dodgy valve holder. So that's something to investigate. So, just check channel A is still sensible. Yeah, still looks good. Yeah, channel A still fine. So, left side channel B doesn't work right. Okay, let's try the other side. This is going to be through this 1A5 plug-in, which is a bit more complicated. So we'll ground both inputs and plug in to right channel A. It's fairly near ground, that's a good start. Does the position control work? Yes, not very far, interestingly. Let's see what the gain's like. So, do the same test. Start with our 1 volt signal at 0.2 volts per centimetre. That might make it 0.5 volt signal at 0.2 volts per centimetre. DC coupled, and plug that in. Okay, so we have 0.2 volts. 0, 0.5 into 0.2 volt per centimetre, but the amplitude seems to be a bit low. It's only showing it's showing half the amplitude it ought to be. It's interesting. Maybe that is actually correct and the other side is wrong. Don't know. There's a attenuator balance problem with this. Always like that. Just a step attenuator balance as it warms up. Try 1 volt per centimetre, 0.2. Yeah, that's showing 2.5 divisions. So that one is giving correct readings at 50 millivolts per division instead of 100 millivolts per division. That could be because the left channel output is broken and so it isn't doing its differential amplifying thing properly. Let's try channel B. Let's go back. Center that and move this output to channel B, or across output B of the right channel. That is way off the bottom. It's not good. Let's go and have a look for it. still way off the bottom, and with no apparent signal on at all. Right, now this is the channel that has the dodgy looking valve in it. Let's have a look. Let's pull that out. Is it hot? Yeah, fairly. Pull the valve out, doesn't make any difference at all. None at all. So, this is the dodgy looking valve. Again, no getter visible. Telefunken ECC81, made in Germany. Let's put a fresh one in. I happen to have some I prepared earlier here. Now these, also made in Germany, but a different Germany. This is a RFT ECC81 on the other side of the Berlin Wall. Let's see if it works. Let's pop that in again. Power on, probably all right. There we go. So let's let that warm up. Does anything change? Take a few seconds. Do we have an output? No, we still don't. Oh yes, something's happening. There we go. Oh look, it's heading back towards the middle of the screen. Let's put the position back somewhere where we can see things. Ah, we have, look at that, an output. Compensation's all wrong, but there's something there. That's good. There we go, that was an easy fix, wasn't it? So now let's have a look at the gain. So we've got this 0.1 volts per centimetre. It's still going up. 1 volt. And, yeah, so that's working backwards. 1 volt, 0.2 volts per centimetre should be 5 centimetres. This is the 0.1 volts per division. It's giving us 2.5 divisions. So the gain is again half that of the other channel. But that is indeed working. And it looks like the offset is alright too. Oh, hang on. Let's centre the trace. Where's the trace? And centre that. And I'm not surprised. We may need to adjust DC levels, having replaced the valve. Sorts of things all over the shop. Oh, that's a very sensitive adjustment. So, very noisy. There we go. So that's showing negative, as it should do, and if we change to the other to output A, we should get the same waveform but positive going. Yeah, but oh, offset's all wrong. Should probably set this up properly because I bet oh my goodness, dirty control. The 0 point on this is probably not all that well defined. It's a bit arbitrary. But there we've got negative, and there we've got positive. A lot of noise on that trace. I think that high frequency compensation just needs adjusting. So, conclusion is, on the right channel, both A and B work now. We've replaced one valve, and with a sensitivity of, well, they give correct sensitivity when the scope is set to 50 millivolts per division. On the left hand side, things a bit different. A works and B doesn't. With correct sensitivity when the scope is at 0.1 volts per division, which is interesting. Now, I suppose it could be a difference in the two plugins, and that's not bad. So let's try swapping the plugins over just to eliminate that variable. Switch off. As far as I'm aware, both of these plugins are in good working order, but just to be sure, I'll swap them over. So channel B on the right output B on the right channel needs some tweaking to get the high frequency response correct, and output B on the left channel also needs some tweaking to get anything sensible out of it at all, unless that involves tipping this whole thing up onto its side, which I don't think I'll do today. Right, so let's try connect what is now the right channel with the plug-in swapped over. So, what do we get? Wait for it to warm up. Click. Right, and now, there we go. There's something there. Whoop. Warming up. DC levels all over the shop. Doesn't surprise me. Let's cheat and bring that up. Ah, okay, so that is showing 0.2 volts. Tweak DC level. Not really zeroed. Quite easily really sensitive. Well, okay. So, this is showing the same thing. Yeah, the 50 millivolts per centimetre position is correct. So, let's just check the B output, which should be the inverse. Which it is, apparently. It's sitting up properly. Yeah, so that's working. Okay, so left channel I think is the one with the problem, demonstrating twice the sensitivity it should have and total nonsense on one of its outputs. Try this. Yeah. Okay, so partial success there. There's a gain adjustment. I wonder if that's been misadjusted. Don't know. I think let's get it working properly first of all. That's interesting. Why is that happening? Yeah, there's something dodgy here. Look at that. Everything shifts around when I wiggle. Bash. Okay, that's enough for today. A reasonable amount working, but some jobs left to do. Thank you for watching.